Here I've got a problem that's a little more difficult. It's a word problem, and we're going to turn it into a math problem and solve for the resultant vector. So let's go through it. So a person walks 100 meters, and they walk at 20 degrees south of east. After that, they turn 60 degrees towards the north and walk another 75 meters. Finally, then, they turn and walk 45 degrees north of west for another 80 meters. So sketch this and find the resultant vector. So let's start by sketching this, and let's take it one step at a time. So we'll have our starting point, we'll say here. They walk 100 meters at 20 degrees south of east. So let's draw our x and y axis. This is x, this is y, just for reference. So they're walking 20 degrees south of east. So we'll say that's something like this, where we'll call this angle something like theta 1, 20 degrees, and we'll just say this is A. So we have one vector, and A, we'll just note stuff down as we go. A, magnitude is 100 meters. So we've sketched out one of our vectors here. Now, they turn 60 degrees towards the north. This does not mean it's 60 degrees north of east, like north of the x-axis. It means from this position, they turn 60 degrees north. So we're just doing a rough sketch here, so things might not be accurate. But they turn 60 degrees north from this position. So theta 2, we'll say 60 degrees. And we call this B. And B is, they walk for 75 meters. So we'll say our magnitude of B is 75 meters. Then finally, they turn and walk 45 degrees north of west. So 45 degrees north and then west. So they're going 45 degrees this way. And notice it is north of west this time, so it's north of the x-axis. So completely horizontal line. So this is 45. And that is, we'll call that C. They walk for 80 meters. So C, magnitude is 80 meters. Okay, and so that means, if I just grab another color here, this from the origin to here, this is our resultant vector R. So we need to find the magnitude and the direction of this vector. So let's go ahead and do this. So first of all, before we start, it is important for a problem like this to have our angle convention understood. So I've said this in other videos. Positive angles, 0 starts here and positive goes this way and negative goes this way. So looking in this case, if we look at theta 1, this goes down 20 degrees, so it's negative 20. So this should actually be negative 20. And we will start with that. So let's start with A. Let's find the components of the A vector. So we can find, you can start with either, let's start with the x component with our cosine equation, and then our x value, our x component is this, plug in our values. Our magnitude of A is 100 meters, and then cosine of negative 20 degrees, and that gives us, now this gives us a positive value, 94 meters. And you can tell you want it to be positive because we're going along the positive x-axis here. So you can make checks like that as you go. So let's do the y component. That's just 100 meters. Sine of negative 20. And that, when you put in your calculator, is minus 34.2 meters. And again, the negative makes sense because we're going in the negative y direction. So that works out. So let's look at B now. So we have our A components. Let's look at B. So I'm going to draw out starting from here, starting from this point. Draw this vector out, and then this is the 60 degrees here. Now we want to find the angle with respect to the x-axis, and we don't have that here. So we want to find, if I draw this out like this, we want to find this angle, and I'll call that phi. We want to find this angle so that we can find the x and y component. So how do we find that from this? Well, we can come up with a relation here and say, because we know this is 60, and based off of geometry, this angle and this angle here, which is just this, are the same. So by geometry, these are equivalent if we have these horizontal lines here. So this is 20. This is 20 degrees. And so our 60 degrees is just this plus this. So if we want to solve for this angle, it's just our 60 degrees minus theta 1, or 60 minus 20, which is 40. So now we can use this value to solve for the components of B. So let's do that. Same formulas here. Bx is B magnitude cos theta, which is the magnitude of B is, he's walking 75 meters, so 75 meters times cosine of 40 now, and this should be phi. And that gives us 57.5 meters equals Bx. Now By is 75 meters sine of 40 degrees, and so that is 48.2 meters. Okay, perfect. Now we have the components of A and B, and now let's do C. So I'll get a new sheet. So C, we're starting here, and we know our angle with respect to the x-axis is 40 degrees. And again, we have to note our convention. So, our convention for angles, that is. So we are, let me draw it like this. It's 45 degrees with respect to this axis. But our angle starts at 0 over here. And so by convention, we should use this angle to denote where this angle is relative to the xy coordinate system. So really, what we want to do is we want to take, this is 180, and we want this angle, which I'll denote by that symbol. We want to find that angle, which is just, if I'd go like that, 180 degrees minus 45 degrees which is 135 degrees. So if I draw it on here, we're really using this angle here. And that helps us to know that if we just use positive 45, it'd think we're going 45 degrees this way. But if we have the 135, it knows we're going towards the top left instead of the top right. And so that's why that convention is so important to keep track of. And it can be hard to keep track of. So let us find the components here. So our magnitude of C, if we just recall, is 80 meters. And now our angle is 80, or our angle is 135. Yeah. So our x component is just 80 meters times the cosine of 135, which works out to negative 56.6 meters. And then cy is 80 meters times sine of 135, which is positive 56.6. And again, to check if the signs make sense, we're going in the negative x direction, so that should be negative. We're going in the positive y direction here, so this should be positive. So it checks out. So now, to find the resultant components, we have all the components of each individual vector, and so now we add the components to find components of R. So what this looks like is we take our AX component and our BX component, if I can find it. So 94 meters plus 57.5 meters plus negative 56.6. And that's our Rx. And that turns out to be 94.9 meters. And then our Ry component is just negative 34.2 plus 48.2 and then plus 56.6. And that gives us 70.6 meters. Now we're getting somewhere. So now, using these, we can find the magnitude of the resultant. So the displacement, essentially, of how far the person walked, which is just the square root, well, it's just Pythagorean's theorem, the square root of the two components added together and squared, like this, which comes out to a magnitude of 118 meters. And then finally, we can solve for the angle, which is just this angle here. We'll just call that theta. And that is the arctangent of the y component over the x component. Which is simply rounded. If we round the answer, it's 37 degrees. And for the last thing, as always, write out your vector. So the resultant vector is 118 meters at 37 degrees, and we're in the first quadrant with respect to the x-axis, and so we have north of east. And that is the final answer. So that was a bit of a more difficult problem. Um, and of course, if you have any questions about it, if anything's unclear, feel free to leave it in the comments and I'll try to answer anything. But that was a bit of a more involved problem and hope you found it useful.